Today we're going to work with trigonometry, and we can use trigonometry for a lot of different things. Squaring up houses, squaring up decks for on houses, on trailers, anything like that. We can use it in navigation, anything like that. So it's very, very useful. And when we talk about it, we're going to talk about triangles, and namely right triangles. Notice we have a right angle at angle C, and we'll just go ahead and name some of the parts of a triangle. Got angle A, or in our case, we will denote it as theta. And we have a side opposite theta, or opposite angle A, and that's called the opposite side. And an adjacent side, which is the side right next to the angle A, or theta. And the opposite side of angle C, which is always the largest side, the longest side in a right triangle. It's opposite the right triangle, and that's called the hypotenuse always. So in every right triangle, we have some trigonometric identities, namely the sine of theta equals the opposite side divided by the hypotenuse. And the inverse of the sine is the cosecant. And so if we would flip the sine, we would flip the right-hand side also. So the cosecant is equal to the hypotenuse divided by the opposite side. Again, the sine is the opposite side over the hypotenuse, and that's what we will mainly use. We also have a trigonometric identity that relates the cosine of an angle to the sides. And the cosine of theta would be equal to the adjacent side divided by the hypotenuse. The opposite, or the inverse of the cosine, is the secant. And again, we would flip the right-hand side, and the secant of an angle theta, in our case, equals the hypotenuse divided by the adjacent side. Lastly, we have trigonometric identity tangent. The tangent of theta is equal to the opposite side of that angle divided by the adjacent side to that angle. And again, the inverse of the tangent is the cotangent, and the cotangent is equal to the adjacent side divided by the opposite side. But the three main functions we will use in this are the sine, cosine, and tangent. Now I'm hesitant to put A over C or B over C for the adjacent side over the hypotenuse, or something like this. It's always better to remember that it's the opposite side over the hypotenuse is the sine. The cosine is the adjacent side divided by the hypotenuse, and the tangent is the opposite side divided by the adjacent side. A reason for that is if we take another angle, let's say we are looking at an angle beta, we'll simply change the way we're viewing the triangle, such that now the opposite side will be the adjacent side, and the adjacent side will now be the opposite side. So when we have that, we would have something that looked like that right there. If we're looking at beta, the opposite side is now the side between A and C, and the adjacent side is the side between C and B. The hypotenuse remains the same. So let's look at an example of this. We're given a right triangle as shown, and the points we do not know are side A, side C, and angle B. Now, since we are given that it's a right triangle, we already know that all triangles add up to be 180 degrees. And we already know two of the angles because it is given that we have a right triangle. So one of the angles is 90 degrees, angle C namely, and the other angle is given as 28 degrees or angle A. Putting these figures into the triangle and knowing that a triangle equals 180 degrees, we have 180 degrees equals angle A plus angle B plus angle C. Angle A is 28 degrees, so we're going to substitute 28 in for angle A. Angle C is 90 degrees, so we're substituting 90 degrees into angle C. So the only thing we do not know is angle B. Now, notice we have common terms on the right-hand side of the equation, or namely 28 degrees plus 90 degrees, and that's going to equal 118 degrees. So we have 118 degrees plus angle B equals 180 degrees. By subtracting 118 degrees from both sides, we will end up with 62 degrees equals angle B, which is the only thing we have on the right-hand side. We now have all three angles of the triangle, and we have solved one of the unknowns that we were looking for, namely angle B. Well, let's say we want to find side A. What identity would we use? We go back to the previous section. We know that the sine equals the opposite over the hypotenuse, the cosine equals the adjacent over the hypotenuse, and the tangent equals the adjacent or the opposite over the adjacent. So to find side A, we can use two different trigonometric identities, and those would be the cosine of angle A is equal to the adjacent, which is 34 over C. And we also could use the tangent of 28 degrees, or angle A, is equal to the opposite, which would be A, divided by the adjacent, which is 34. So we have that as seen, cosine of 28 degrees equals the adjacent, which is 34, over the hypotenuse, which is C. Likewise, we have tangent of 28 degrees equals the opposite, which is A, divided by 34, the adjacent side. Manipulating the equation for the cosine, we have the hypotenuse equals 34 divided by the cosine of 28. And solving for the opposite side in the tangent function, we just simply multiply both sides by 34. In either case, we're going to get that the hypotenuse is equal to 38.5 inches, and the opposite is going to be 18.1 inches, which is a mistake that I have right here. And so, correcting that mistake, we will find that we have 18.1 being the opposite side. Now we can solve for A. We already solved for A. But let's say we just looked at the cosine to begin with. We can solve for A by using a sine function now. Sine of 28 equals the opposite side over the hypotenuse. Let's say we did not use the tangent in the above example. To solve for the opposite side, we already know that the hypotenuse is 38.5. So we would multiply both sides by 38.5. And by doing so, we get 18.1 equaling A. Where the sine of 28 degrees times 38.5 equals 18.1. And that is in inches. And we could also notice that we have a right triangle. And in any right triangle, we have the hypotenuse squared, or c squared, equals the sum of the legs squared, or namely a squared plus b squared. So the equation would be, using Pythagorean's theorem, c squared equals a squared plus b squared. Now, if we substituted 38.5 for our hypotenuse into that equation and 34 for b into that equation, we would subtract them to find a squared. So when we do 38.5 squared, we get 1,482.25, and 34 squared is 1,156. Subtracting those two quantities, we get 326.25. That equals a squared. So we need to take the square root of 326.25, and that gives us 18.1 inches equals A. Now from this, you should be able to see that there are a variety of different ways that we can solve for the unknowns. It does not have to be exactly in the order I presented it. We could have solved for A and C first and then found the angle. And we could have found A first and then C, or we could have found the hypotenuse first and then A and then the angle B. All types of these problems will relate to that form.